man, where are those guys? Ah! You guys made it. You didn't forget we were racing, did you?
No, you spanked me. Tell me what you did.
Well, it's just simple physics stuff. Mass, resistance, gravity, picking the right line down the slope. Your skis have a lot to do with it. And your tuck is important. Let me see your tuck position. Okay, well, see how the poles are up here like this? That creates a huge amount of wind resistance. What has to happen, you've got to get the elbows out in front of the knees and lay right down on the knees and just get as thin as possible. And then let the side cut of your skis do the turning for you. Just pure carve, no skid in the turn.
So what, are you an engineer or something?
No, I'm not, but engineering principles apply, and my skis were definitely designed by engineers. Funny you bring that up. Is that a career you're interested in?
Yeah, I think it would be kind of fun.
Oh, excellent. That's really one of today's best careers. At the community college, we have several degree options that lead directly to engineering jobs, or you can transfer a program to the University of Utah.
Cool.
Or other colleges. Are you taking the right classes in high school?
Let's see, I've taken physics, multiple math classes.
Choosing a career is one of life's greatest challenges. How do you decide? Is there a process? Maybe. At least there's a starting point if you know where to look.
Growing up, I knew that I liked to build things with Legos or an erector set, or, I don't know, make sandcastles, build, I don't know, whatever as often as possible.
The starting point to a career decision is to analyze yourself to see if there's something you're good at, or something you love to do.
One of the big things that let me know that I'd probably be a good engineer or mechanically inclined was when I was in third grade, we had a sixth grader in my neighborhood who wanted to repaint his bike, and he took the whole thing apart down to the sprockets and ball bearings, things like that. And he couldn't put it back together. In fact, he had it in a bucket in his backyard. And I asked him what it was one day, and he said, "Oh, it's my bike. I can't get it back together." So I asked him if I could put it back together, and he said, "Yeah." I'd never seen a bike, never seen it taken apart. Put the whole thing back together for him. It took me about 2 hours or something like that.
I grew up kind of in an engineering family. My dad's an engineer, so I think I kind of grew up just with the mentality of kind of take it apart and see how it works, or just do it on your own. So, I grew up, helping my dad do, changing oil in the car, and I think we just kind of grew up a very hands-on technical family.
Is there a common thread between all engineering professions and people that go into the engineering field? Perhaps.
I think it's kind of just the common interest of how things work. It's just the fascination of how is this going to work, how is this going to be better. I think that's kind of the mentality of how can you always make it better. How can you make it quicker? How can you make it cheaper?
If engineers had anything in common, it would be the ability and enjoyment of solving problems, meeting people's needs, and producing a product that maybe nobody else has done before.
There are a lot of misconceptions about engineering. Many people think that you've got to be a math genius in order to be involved in technology, but that just isn't the case. Certainly there are careers as engineers that require an awful lot of math and science. They're very analytical. These are the folks that are designing new technologies and developing state-of-the-art products. But there are also those people who then say, all right, this has been designed, how do we build it? These are manufacturing and process engineers. Then you've got the people who are responsible for maintaining and calibrating and certifying that the things that are built are actually doing what they were designed to do. Highly trained technical positions don't require a lot of math and science. It's a very hands-on, a very applied technology, and there are great careers in that. And then finally you've got those people who are trained as operators to use the equipment that's been designed and developed. At Salt Lake Community College, we have programs that span the entire engineering continuum, starting with one-year certificate programs that train people as operators, continuing on to Associate of Applied Science, which is a 2-year solid technology program that would prepare students to enter the workforce. We also offer Associates of Science degrees, the first 2 years of a 4-year degree in engineering technology that would transfer to Weber, UVU, or SUU. We also have the Associate of Pre-Engineering program, where you can do the first 2 years in a 4-year engineering science degree. Those programs would transfer either to the University of Utah, Utah State, or BYU.
At the University of Utah, the College of Engineering departments work jointly with research teams such as the Scientific Computing and Imaging Institute. Bioengineering is seeking to improve medical imaging by converting data gained from CT scans into complex 3D images. Doctors then can use the 3D images to plan and practice a dangerous and sensitive surgery to increase the likelihood that the surgery will be successful. In material science and engineering, students use laser equipment to develop new materials that have never before been produced.
I'm a graduate research assistant in material science and engineering here at the University of Utah. And my first year here at the U, I was able to use this cutting-edge tool, a pulse laser deposition system, to work on research relating to energy issues in our society. The pulse laser deposition system is truly amazing because it uses a focused ultraviolet laser to produce a plume of plasma. So it literally rips atoms off of a target material and deposits them on a substrate, literally atom by atom. And it allows us to produce quantum nanostructures, which are very useful in realizing better energy conversion technologies.
We have 8 different undergraduate majors that we offer to students. We have biomedical engineering, chemical engineering, civil and environmental engineering, computer engineering, computer science, electrical engineering, material science and engineering, and mechanical engineering. Approximately 40% of the students in our College of Engineering have transferred in from other institutions. So the University of Utah works really well with those transfer institutions to make sure that the classes that students take articulate or transfer in, and students can receive credit here at the University of Utah for the classes that they've taken.
Engineering firms specialize in creating products that have never before been created, or that are customized, one-time products that cannot be built in an assembly line.
Doing things that have never been done before. Pretty cool.
Once you get into school, just be aware that there's so many aspects of engineering that you don't even know they exist. And sometimes those are the greatest jobs.
A high school student in Utah has very strong opportunities in engineering and design.
High school is a perfect place to begin preparation for engineering careers.
If you're a student in high school and you want to go into a design or engineering career, obviously math, science, chemistry, anything of that nature is going to be very beneficial.
Math and science classes are a key part of the background you'll need. Also, if your high school has an applied technology center, you might be surprised to find what's offered there.
I had no idea all the stuff that we would do when I came into this engineering program. We've built radio transceivers that can send radio signals. We've built marble sorters that can sort by color. One of my favorite projects was that we designed a cell phone, and we were able to put in any kind of feature that had popped into our minds during the brainstorming process.
I really love engineering because you can create anything you want and you can be anybody you want to be. One of the things that really drew me to engineering was the fact that scientists may explore the world that's around us, but engineers create the world that doesn't even exist yet. I get to create whatever I want. In one of our classes, we get to create our own invention. We design it, we manufacture it, we test it, and we present it. And it's really given me an opportunity to learn everything I can about what being an engineer is.
Physics, particularly a basic conceptual physics course, is a great foundation for studying engineering because all disciplines of engineering require you to understand why things work the way they work, why the world and the universe works the way it works. What I love about physics, and I think one of the ways physics overlaps with engineering, is that you get to do fun things and you get to figure out why those things happen the way they happen. The buoyant force on a boat is equal to the weight of water displaced, which has everything to do with the volume of boat that's underwater. But volume also has a lot to do, volume and shape have a lot to do with stability and whether a boat is tipsy or stable in the water.
Go, Jenny, go!
Our boat project is a good example of an introduction to engineering. We first learned the concepts, the physics concepts involved in floating and being stable. So a huge part of understanding Archimedes' principle is figuring out how much volume of water, in our case water at the pool, is displaced by the boat. Who had a boat that wasn't the same shape, a different boat? Yeah, Melody's.
We had like a really good idea. We had a T-shaped boat where we had like a box under a box, so the like box would help like it float more as if like an air pocket kind of, and then we put 2 boxes on the sides as platoons, you know, so it was a T shape, and we thought that that way like they would balance, and then the girls would have their legs sticking out the opposite sides that the 2 platoons like weren't there, so that it would be like completely like equal, do you know what I mean? So we did that, but then the girls didn't weigh enough, so the 2 side platoons didn't like go down enough, so it was like wobbly. So as soon as we like got them in the water, they just flipped.
We both tried to get in at the same time, but it started to feel unstable, so we tried to even out the weight, and then we just flipped.
Yeah, it's because our boat was too buoyant and we didn't weigh enough.
What we learned in high school physics is what engineers have to know to do stress analysis on objects they design.
Utah is a great place for engineering careers. With literally hundreds of technology and engineering companies, there are wonderful opportunities in a number of engineering-related jobs. To make engineering your field of choice, get started right now in middle school, junior high, or high school by taking math, science, and technology classes, or even a specialized Applied Technology Center engineering program. After high school, Utah's colleges and universities offer certificate, associate's, bachelor's, master's, and doctorate programs in engineering.
Hi, Susie. How are you doing today?
Good. How are you?
Good. Hey, have you had a chance to think about some of the things we talked about last time we met?
You know, I've been thinking about it, and I'm really interested in chemical engineering.
Chemical engineering. How interesting. Why did you have an interest in that?
Well, I've always liked math and science, and I really enjoyed taking chemistry in 10th grade, so I thought that'd be a good career choice for me.
Visit your counselor or career center to see what's offered at your school and to choose a plan that will help you take the right courses. Engineering is a great field, offering some of the best pay in Utah and plenty of Utah companies to choose from. Engineering. Step ahead into your future, your design.
We're doing things that have never been done before. It's pretty cool.